I have been building an open source platform to replay production traffic locally. And before I show that platform, I want to, like take you through why I'm doing that and like what are my experiences that have led me to build this sort of a open source platform. So philosophically, I don't know if technically you might have experienced this graph, which basically says, when you code, there are requirement, architecture, coding phases, and then early you catch the bug. The cost of fixing that bug is less, which means if the bug is introduced in requirement phases and it's caught in requirement phases itself, wherein typically you're discussing requirements with product manager, etc. That's where the cost of fixing that bug is almost nothing. Whereas if you introduce that bug in architecture and fix it in architecture, it's again not much. Again, when you introduce that bug in coding and fix it in coding, it's not a lot, right? So you might have seen those triangulars, and you might have seen those cost to fix that bug keeps increasing as you move towards production. But in any case, whenever you introduce a bug and then it gets caught in production, the cost of fixing it is very high. And I want to, like, I have experienced this myself throughout my career, and I want to tell you, like, that experience has led me to build what I'm building, right? So I have worked in companies like Flipkart, Airtel, PayU, and Ola. So Flipkart is like Amazon for India. Airtel is like Deutsche Telekom. I don't know the telecom here, but it's like a telecom company in Asia. And PayU is like maybe Klarna, Stripe, Klarna for India. And Ola is Uber for India, although there is Uber for India. But um, and one of the most common things across all these companies is I've lived through the big billion day deployments, and I've lived through the anxiety of these big billion day deployments. So big billion day deployments is like a Black Friday sales equivalent for Asia, right? And you might have seen like a lot of discounts, and you might have seen like a lot of promos and offers going on, and the volumes of sales on your e-commerce websites just shoot up. So I have been behind the other side. I have been on the other side of developing such solutions, right? So I want to first tell you like why bugs make it to production. What I'm building is just a small part of, a small part that addresses one of the reasons. The reasons bug make it to production is far more than just, like three reasons, but I've tried to categorize them into, three large buckets. Um, so the first one is, as you grow beyond, say, a team of, like maybe one or two products or 10 people, or you grow into several platforms, dependencies set in. What do I mean by that is you end up depending on microservices of other teams. And then these teams are moving async always. So hypothetically assume a company which has a payments team, a cabs team, and say a restaurants team, right? And this restaurant and cabs would depend on payments for their checkout experience. So customer buys something and they buy using payments team's APIs, right? What now happens is there is some Christmas coming, and then the product manager comes, and product manager from restaurant team comes and says, hey, I need this change in payments API because I need to implement this couponing logic. I'm expecting a surge in usage, and this couponing would give some sort of a discount in the payments API, right? So the payments teams agrees. They say, yeah, happy to do that. They make these changes and they test all their changes with their own unit, their own integration tests. Everything is good, and they deploy. So all well, right? Except, few days later, some of the cab team users start seeing, horrible payments, horrible experiences, or abnormal payments in their own checkout experiences. So this is a real screenshot of a user in Delhi who got who took an auto ride which was supposed to cost them 62 rupees, which is like 0.5 euros, but it ended up costing them about 1 million euros. And So the way this cab company works in India is that you can't really go. The payments are not through the cards; they have to be paid in cash. So unless you pay, the auto driver won't get the next ride. So there was like a big tussle until the guy paid this amount. The auto driver won't let the user go, and the cab company has no customer care. So there's nobody you can call, or there's nobody you can. It was a big news. I'm sure something similar must be happening here as well. The other user got another, like this user got about 150K USD, and the other user got about 1 million USD bill. And they had a pretty bad week. That entire week, Twitter was all about how bad this company is, whatnot. There were memes about this, and this is what production issue costs you. So what typically goes wrong? Um, um, One is, upstream dependencies are usually not known. In the sense, if I join a team completely new, I really don't know who's using my APIs. I'm talking of a fairly large setup. I'm not talking of a small startup company here and there. But say, the company is at least 50 microservices large, right? So the problem is, nobody knows what the upstream dependencies are. No one ever cares that, for a change that I do, I will test all the upstream dependencies. Says no one ever. All they do is they check their own downstream dependencies and what they depend on. If that works fine, they just go ahead with the things, right? Like there is nothing, because my job is done, all tests are passing. So, like I think I'm done with it. And then what happens is, typically when you see in this diagram where uh, mocks are outdated, like what mocks you're using from the other team, they haven't been updated, and there is typically such communication is lost in emails or some Slack, or like, hey, I sent you a message but I didn't read it, so on and so forth, right? Those integration tests, since the dependencies are set and the deployment cycles are async, those integration tests are not triggered in time. Imagine 50 microservices having so many dependency tests. The product manager or the business owner would say, if the tests are passing, just go ahead with the deployment. Why bother, right? And then, like I said, the communication is usually lost in emails, right? Um, the other second big reason why production bugs are, why production bugs occur is the production setup is very different from your local setup. And this meme sort of puts it in a way I want to, but this is technically how a production setup would be very different, right? I have just noted only a few things that I think I could note down only these things which are different on production, but I'm sure there are more, right? Um, and then the third thing is, there are too many scenarios that one has to cover once your product hits production traffic. By this, what I mean is, people say, hey, follow TDD. Like think of writing tests before you even write the code, which is absolutely right. But you do write TDD, or you follow TDD, and QAs and devs can cover scenarios only what's humanly possible. It's almost impossible to, like your users, your software's users will always find innovative ways to interact with your software, and you wouldn't have even imagined. And it's humanly impossible to think of a test for that before you even write the code. So here is one example. So um, here is another web page of a very famous e-commerce company that is about 50 to 60 downstream calls just to render this one page. And what happens now is, even if a developer is to make 58th service change in this hierarchy, they have no clue, or they have no way of testing all scenarios on this web page. Imagine this is just one product, right? They have millions of such products. And then, like I said, upstream dependencies sadly are not really known. So making a call change in, making a code change in 58th service, in this hierarchy, it's super hard. And what then happens is, people just keep adding more services, more code, right? And that just adds up to more tech debt. Um, so, so I've spent about what, like 14, 15 years, and I have been in the debates where TDD versus no TDD, or I have sat down with people who said like only integration tests are important. I've sat down with people who said unit tests are the most important thing out there, so on and so forth. But humanly, I mean, my realization is that humanly it's impossible to cover all scenarios, and that sort of led me to build this open source product. So um, we are on Git. This is our link. If you like the product, please star us on Git. It's, by the way, it's open source under MIT license, so you feel free to use it as it pleases. I want to first show you like what the like how does it work, and then show you the demo. So essentially there is a IntelliJ plugin, and this plugin keeps observing code changes as you write the code, and we have a dependency which you can add in your POM. So I'm assuming everybody has a Java background. Yeah. Yeah, I know, I'm just making it sure, because when I say POM, etc., it shouldn't sort of. So you add a dependency in POM, and what this dependency does is it automatically starts logging the code execution as you execute it, and then whenever you make a code change in say a method, or like somewhere inside the class, we trigger just the necessary tests, and these tests are saved in the form of a simple JSON which you can commit inside your Git. So I would first show you the demo and then come to the next part. So this is a very simple project which I've written, and it's a simple Spring Boot project where like I have assumed a method where I have written a method which is can deliver. It takes a customer ID and it makes a database query, and it figures out if what is the location for that customer. Then it makes an API call, and then it figures out all the available units, and then it filters the available units per the location, and then we make a simple check which says if the available units are 0, just return null, and if the precipitation in that area is less than 3, just set the flag to set the deliverable flag to true. I'll set it to false. So what we are going to do is I'm going to show you a very simple record and replay demo, and then tell you how this same thing can be done for production as well. So the first thing is I go and install this plugin from go to IntelliJ IDEA, preferences, then plugins, then I search for this thing called unlogged. Yeah, so about 10,000 people have installed us, and quite a few of them are already using us. And then once you install this, you will start seeing those icons next to your methods. I'll shortly explain what those icons are. So let me just open this. Okay, so it is showing the session from previous this thing. So you have to add this dependency, which is unlocked SDK 0.5.0, whatever the dependency the plugin expects you to do. Then the next thing is you just have to add this annotation at unlocked, and once you add this at unlocked, you don't need to do anything. You just need to start your application in debug or run mode, and everything else happens automatically, right? So when I start the application, I open this plugin, and you can see that you can see a live view of what is happening inside your application. So this live view has a few things. Every method, how long did it take to execute? Every method, which lines of code it went through, what are the input arguments, and what are the return values. I'll tell you why this also. So let's go back to our original code. I just want to take a pause. Like, are there any questions you have? Nothing so far? Yeah. Okay, so I'm going to go back to the code. The other thing I ended up building was, if I'm deep inside the code, right, I have uh, to debug it, I have to either expose an HTTP endpoint and then go to Postman or some REST client and then do F8, F8, F8 till I come to the part which I'm debugging, or I have to write a unit test. So I wanted a quick way of trying out some piece of code very quickly inside IntelliJ. So I created this thing called direct invoke. So you click on it, and then we let you execute just this one method with the input arguments. So you can see that on the right side there is a nice UI comes up wherein you can fill in details like customer ID is 10, um, Shardul, the address is say London, and right, and then you can just execute this method, you get a response right here. Now I was trying to show you this earlier where I was telling you that look, every time a method gets called inside your code, we show you this. Are you able to see this green um, you know so green icon? So what we show is we tell you where the code has executed very recently for that method, and we also show you like the time it takes to execute that line. Why this? Because typically, like when there are performance issues, we were asked to debug only when the API is live. So backtracing that to the last method where what was taking a lot of time, that took a lot of that took a lot of efforts and putting bits and pieces together. So this particularly helps us pinpoint which line is going to take a lot of time, and then maybe go around and fix it, right? So the next method I'm going to call is get all customers. So this method has no argument, so I can just execute it directly. Um, you can see that the live view is popping up everything that we do inside the code. It also shows up in inlay hints here. So hey, we have made one call that has taken 108 milliseconds with a 0 microseconds deviation. So you get to see for how many calls, like how is it behaving, right when you are coding. Then the last thing I'm going to do is I'm going to call this can deliver. So what I did was I called this add new customer with a dummy customer profile. Then I just called get all customers to check if the customer I added is inserted into database or not. And then I'm going to call this can deliver. Now, so the plugin automatically figures out what needs to be mocked. When it comes to replaying traffic locally, right, a lot of mocking needs to happen. Now, today the mocking or way people sort of mock is they use test containers or they use something like Docker to emulate DB or other things. And my personal frustration was that I had like several services and I had to make all of their Dockers, and I had to, I mean, somebody else made it, but I had to still keep them running on my laptop. So even once if my laptop shuts down, I had to sort of bring them up again, and that was quite frustrating. So we did this thing called inline mocking. So you don't need to, in your JVM itself, you would be able to mock. So in the running program itself, you can tell the JVM not to call a particular line. So I'll show it to you shortly. But whatever lines can be mocked, they show up like this ghost icon. So you click on them and you can actually define the mock of when and then. So essentially when the customer ID, so I've clicked on say customer profile repo, just hold on. So I've clicked on this one, customer profile repo dot get customer ID, and then I can actually define a when and then condition for that. You can even use recorded data to define this when and then, which means if the mocks are enabled, the next execution will not call the DB. It will just mock, the dependency. It will just execute that when and then condition. Yeah. So let me just call this can deliver. I go to this execute method. Say 10. Yeah, so I get this response, and now inside our live view, we see several methods popping up. So what is happening is it is showing all the methods that are called even in other classes. Say for example, this um, weather service API, right? So the weather service dot get weather info, all of that is also called, right? So now this is sort of a live view, and what you can do now is just select all, and then let's skip a few methods since they are API calls and I don't really want to create tests for them. So I'm going to skip this and I'm going to say save. Now what we do is we define assertions for you. So now you can see that there are 6 replays we have selected. There are 7 downstream calls that we are mocking, right? So you can expand and see which these calls are, and there are 97 assertions we define for you. So these assertions are defined on the return value for each method. Now what we do is we omit all the noisy fields, and we are looking at the code and we figure out what is the important part that should be asserted, and then we define the assertions for you, so you don't have to do even that. And then we let you define if a replay test needs to be saved in either unit form or integration form. So if you save it in unit form, all the mocks get applied. If you save it in integration form, the actual calls would happen. That's the only difference. So I say confirm, and then that's it. You have all the tests saved. Where are these tests? Inside your test resources / unlock folder. So let me just refresh. So let me show you how one replay test looks like. Yeah. So let's just go to delivery service, and this is a simple JSON which says, hey, for this delivery service, add new customer, which is this basically. What are the lines covered? Line covers are 57, 58. That's sort of a meta for us to track code coverage, and it also helps us to track what is to be logged, what is not to be logged. So I'll come to that part as well. Then we define what is the assertion, which is essentially customer ID, expected value is 10, assertion type is equal. There are several types of assertions you can do: not equal, equal, contains, not equal. I'll quickly show it to you maybe. So you can edit, and then you can define any of those assertions, any of not all, equals, equals, case insensitive. So essentially we have the toolkit that needs to be there for testing all sorts of scenarios with whatever flexibility you need, right? So now it also, this JSON also tells uh, the like the mock definition needed for a particular method. So it says, hey, for this method, just go and implement this mock. So you can see the, let me just scroll down. So this is for delivery service class, all all methods that we saved the recordings for. And once you try the declared mock, basically there would be a declared mock map, and then it would tell you that for this method, if the test is saved in unit fashion, just this is the mock applied, right? So what will happen now? So how do I run these tests, right? So running this test is fairly simple. We say for example, I make a code change here. Uh, I check this condition to maybe say greater than 3, right? And what I do now is I just go to our terminal and I run my favorite command, which is mvn test. So you just run mvn test and the replay tests get run automatically. We have also, so you can see the test run 6, failure 1, and then we have defined a nice format where we say, hey, the typical debugging for the logs that come are horrible. So we went and said, look, let's sort of redo that so that very quickly you can figure out. So we said if the can deliver expected value is true, but the actual is false, right? So we are also figuring out maybe if we can run these tests continuously to keep telling you that this is the scenario you are sort of breaking on production. Um, Now, the other thing is people needed reports, people needed this to be integrated in CI. So we have done that as well. You can run any existing command like so we use this Surefire. I don't know, any of you have used Surefire? So you just run this MVN Surefire report. It picks up from the target folder and it does a very nice report for you. So we have not changed the rest of the pipeline, right? Like we're not expecting people to pick up CI/CD learnings from us. So essentially, now now comes the part where I'll take a pause here. If there are any questions, I'd love to answer. By the way, this is all open source once again, so you're free to take a look at how the code works, how things are happening. If you want me to explain how this is working underneath, happy to do that. But I'll take a pause here before I show how this is going to fit on the production side.
You showed us on Spring Boot with an annotation at the beginning. Does it also work with other frameworks?
Yeah, it should. So it works with all of Java. I mean, we have tested Spring Boot extensively, but it should work on Quarkus and the other one also.
Okay.
Quarkus and what is the next one? There is three, right? Spring Boot, Quarkus, and one more. Mike, yeah.
Is there a minimum version of Java?
Java 8 to Java 21. 22 we are making it happen. So yeah.
Is it compatible with Kotlin or other languages?
Yeah, so we are actually looking for some contribution on open source there, where people can help us build Kotlin as well. So that's an interesting question, but what we have done is we have also exposed this as an agent, so which you can run in runtime, and then Kotlin versus Java is not different. The way a POM dependency is to be added, that works specifically just for Java. But you know, if you're so curious about it, what I suggest is go to our Git, go to unlocked.io, and yeah, you go to unlock Java agent. It's in sync with what we do, and it can be used for Kotlin as well, and help us with issues if you come across. Yeah. Yeah. Any other questions?
Sorry. Can use it also with Spring them with C?
Yeah, you should be able to. Yeah.
Through the annotation as well.
Yeah. Yeah. So we are removing the annotation. Saying if you add the dependency, it should just work. Yeah. So I'll just take a minute to show you this. Yeah. So you know, like we just failed one case and it just shows up here. Yeah. I think we didn't fail. That's the previous one. But yeah, this is how it. Like the Surefire report is a fairly common thing. Yeah.
Yeah, exactly. For the annotation, is it just like as a target methods, or it can be classes also? Should cover all the methods in a class, or?
Yeah, so there is one ask where we selectively just target a few classes versus not. So that is sort of work in progress, but right now you just add in the beginning of where your project starts,
Yeah,
and then we log everything.
it's always like here main, you put it in main, so it will
Yeah.
later detect all the flows in the project.
Yeah, so that is one of the things we will be doing, like that's coming in next 1 or 2 months. So yeah.
Okay, and for the like you for the Maven phases, like you did Maven test, does it need extra configuration, or there is already a plugin for the extra configuration? Like for
Yeah,
example, you
so
have a JSON. Normally, you need configuration for Maven to detect that those are tests.
Yes, you are absolutely right. And we add this one file, which I probably didn't cover. You're right. So inside your test Java folder, you just add this unlog test runner. I think I didn't cover that. Yeah. So that picks up. You are absolutely right. So that detects that, hey, in this JSON, and we have made it like find out if inside test resources unlock folder are there tests. If there are, then run them. In fact, you can actually run it from UI as well. You just go here and click, and then it runs the same test for you. Yeah, you are right. Yeah.
So it's
And then you can see all the test results here. Yeah.
yeah. Thank you.
Anything else?
JUnit 5 or JUnit for compatible?
So JUnit is actual Java code which one has to write. What we are saying is this is just meta around methods which you replay, and then you get a flexibility to replay that in unit or in integration mode. Yeah. So JUnit is a slightly tangential thing to this. In fact, since you are on that topic, um, we did have a utility. Let me see if it's working. Using the same replay, it can help you generate unit test also. But we personally don't sort of recommend that. Reason being, that's against the TDD philosophy, and then you're not really. So I'll give you like a demo of that also. So if I call this method, right? Yeah, so I can select this and I can actually click on JUnit here. Can you guys see the JUnit? It's on top. Can you see it or? Yeah, no. So I was saying using the replay, you can actually generate JUnit. Just click on it and then like you get a quick JUnit generated for you. But this doesn't run out of the box. You'll still have to make small changes here and there. What we do is we do the hard part for you, setting mocks, and typically which is time taking or something that is tedious. So that we do for you, but like you'll still have to um, make small changes here and there to sort of make it work. It does maybe 70-80% of your work, but yeah. Any other questions? Okay, so I'll move on to the next part. So I'll still go into the detail of how this works, right? So how many of you have used Lombok? Yeah, all of you, right? So we have extended Lombok's implementation, and like we were so much in love with Lombok that uh, it works so smoothly for us. We never ever bothered how it worked underneath, and when we actually figured how it works underneath, it was mesmerizing. So we use the same techniques as Lombok does, and to roughly tell you what Lombok does is it adds those getter setters. It's not just adding getter setters. It's not that plain and simple, but all the edge cases, how do they do that? We have covered that in a very nice blog post. If any one of you is interested, so here is our post that talks about Lombok. Yeah, how does the Lombok magic work underneath? So you can actually go and read this and understand how much in depth, how much how much it takes to sort of log nicely without bothering user at all. We have extended similar principles, and then we have also done the logging for you. Now coming to a slightly high level bit, how this is working, like slightly at an abstract level, is when the log, when you execute the methods inside your code, the logs get generated and get stored on your laptop itself. By the way, this is all self-hosted, fully offline, nothing, no data, nothing ever comes to us, right? And those logs are scanned by our plugin. So plugin is also fully built in Java, and then the log scanning happens in our plugin, and then we detect all the replay tests that need to be shown to you, and then you can just click and save them. How many of you have come across this thing called 1BRC? The 1 billion row challenge by this guy called Gunnar Morling. So we have used a lot of similar principles to understand how to the log files are huge in size, and we have actually optimized a lot, so you almost instantly see what is happening in your application. Yeah. Now coming to the next part, where how do you actually deploy this in production, and how does that work? The only difference is you deploy this on production and the logs get stored in some S3 or some storage that you have. Again, this is all on your premise, nothing, no data comes to us. And then we have an application server which scans this S3 data and then pushes the replay test to the plugin. So what happens locally, some part of that happens on the server side now. So it's that simple. Yeah, so like we had one more thing to show, but I couldn't get the demo up and running. We actually built, I'll tell you what it is. We actually built an AI that can figure out if there are runtime issues and fix them automatically. But we couldn't sort of get the demo out. But yeah, next time maybe. So yeah. Any further questions?
So if you could go back to your server, so to your production, so that means, if I understood correctly, that so the application generates logs, the unlogged application server tries to parse them, understands what's happening, and then can somehow live or near real time.
So again, so depending on what machine you put, there would be some delay, but you get almost like 5-10 minutes of delay. You will get what's happening. So whenever you make code changes, you can actually replay like the current live traffic with a difference of 5 to 10 minutes.
Yeah, okay.
Yeah.
That's negligible.
Yeah, that's negligible. Yeah. So yeah. No.
And that means we can then use that traffic to replay it locally.
Yeah, that's right.
Okay.
So now the next two questions. One is what is the performance impact, and the second one is production traffic could be millions of requests. So what do you do? So I'll answer the first question. So second question, and that does answer the first one. The second one is how do you have like millions of things replay tests come to the local? So we have a dedupe logic on the server. So you remember the lines of code traversed, we track that. What we say is, from controller to all the way to DAO, what is the unique number of lines that a API request has traversed. If it is unique, only then log, otherwise don't. So what this means is, only millions don't get logged actually, only a few things get logged, and then you have some sort of a guarantee that all the scenarios are covered. And since the logging itself is fairly limited on production side, the production impact is also minimal.
Okay. And is there a way to, like say, you have a bug in production, to say I want to capture that one, because I want to be able to replay
some
it
of those things are meant to capture exceptions. Some of those things are meant to capture all the crashes that happen. All the like you can put filters that are that can let you. So there are filters we have defined that particularly for this class capture more, particularly for this class capture less, etc. And then you can also say what is taking more than 2 seconds, capture that. So all such things are there. So you can very precisely pinpoint and then create tests and keep testing against those. So there are performance filters, but they're not in this version. You can actually say track only the methods that are taking more than a second, and then it would show you. Then you can track sources. You can say staging or production or local. So sources is essentially which machine you are pulling the data from. It could be localhost or it could be staging. So, meaning you should be able to replay not just production but even staging traffic, right? Like, why waste QA's time when you obviously know that some of the staging traffic is going to go wrong? So you can define multiple sources. So this setup holds true for any remote setting, not just for production, but for any remote setting.
So for Lombok, it's an annotation processing library, but we didn't see any annotation in your code unless the unlocked one.
That is correct. So we are taking care of it in compile time. We don't need like you to do any log unlock.log type of statements at all.
So when you compile the code, you already add
Yes, logging probes.
annotations
Yes,
to be
yes,
later
yes.
processed
So
when you run
so they are called logging
Or something like that?
probes. Yeah. So these are essentially just logging statements, and we add them inside your code in compile time. So I'll probably show it to you once again. So what I did was I added this one dependency, yeah. Then I just came here and on top of my main methods, essentially where my execution starts. So in the Java world, like in different frameworks, it can start anywhere, but I'm just going to say at unlocked. That's it. And so the first thing that's expected to do from you is clean it, so that the target gets clean, and then just start your application. That's it. So in compile time now a new target gets built, and this target file would have all the logging probes. So let me show it to you, maybe take a minute and show it to you. Yeah, so let's just go to this. So we tried on this delivery service, right? Let's just go to target classes, unlogged, and maybe service, and yeah, this delivery service. So look at how logging record event, logging record event. So that's how the decompiled target class looks like. So this is the event ID, and then this is how we reverse map it with what has happened. Does it make sense, or should I explain?
Yeah, and even since it's in the code, later when it's in production, you can get
From
back
production also, yeah.
from
So then think of this diagram. Now all the logs that are generated from these events are pushed into an S3, and then our application server keeps figuring out from these logs as to what is important, and then keeps pushing it onto this plugin. So give me a minute. I'll try to show you. So that's still work in progress, but so the way you would configure a source on localhost is you just go to filter and you say that pull traffic from like a remote server. So I'll show it to you. Yeah, so see here the thing is local. Can you read it? Click on it, and then you can say remote server. So if you say remote server, it lets you define the URL, and then you can just check for sessions. It fetches the sessions on that machine. So when I say the server URL, it is this URL. Let me show. So it's showing no session found, but that's okay. That's something else. Yeah, it is this unlocked application server. And then where do you define which server to push this data to? You define it right here. You just say unlocked, and you just pass one thing called server endpoint. Oh, sorry, so I am in the wrong. I have to update it to 5.7. Yeah, so what you do now is just pass on this server endpoint and then just whatever your URL is. And then you can host this unlocked application server with a simple Docker command. So do that and then you get a URL and then just give that URL to the code here. The code will know that this is to be pushed to this URL and then from there it just happens automatically. Yeah. Yeah. Any other questions?
Do you also have a hosted solution for the?
No, so currently we are figuring out if that is somewhere we can make money. But so Java typically is used in financial domains, insurance companies, where I don't know if people would be comfortable sending their data out. But what we are thinking is maybe we can implement some sort of masking because a lot of people will have PI in production like card data and this and that. So we will give the masking as a paid solution where people can mask this by default and then that mask thing will get replayed automatically. So some of those things are there, but yeah, I mean self-hosted is like a cloud thing is also it's one of our thoughts where we would potentially make money, but yeah.
And how do you handle fluctuating data like, I don't know, stock prices or time stamps or stuff like that?
So that's where his thing where we don't want to log maybe timestamps etc. because the logging solution by default would have timestamp, but when it comes to the extremely high frequency data, we are yet to sort of come across a use case. But yeah, we should be able to because there the latency and all are extremely sensitive in terms of requirement. Like a trading company wouldn't want even 1 millisecond of delay because of extra log added. So there we're probably thinking at a abstract level maybe we can log something and then replay it locally. So the way that would work is you log only on what's on the edges, like an API call, external API call, or a DB call, and then you regenerate the traffic not on production but on some pre-prod or something like that. Did it make sense or yeah?
How do you replay it? This you logging,
Um,
log it, then how do, because you have a production issue,
no,
log it, you have the log files, but and how do you do it on the staging server, test server, just okay, replay it now?
yeah. So the last leg, right? This leg where
No, no,
yeah. So if I understood correctly, you're saying the logging has happened. Now, how do you replay? Yeah.
yeah,
So we have this thing called unlocked application server, right? This server keeps scanning those logs,
yeah,
and from the scanning, it figures out the replay tests, which are unique and which are deduplicated, which are very important for maybe you to replay, and then they are pushed into the plugin that I just showed, the IntelliJ plugin. And this IntelliJ plugin has an interface for you to define the source. So you can say, hey, just show me the replay cases from localhost, show me the replay cases from remote machine. I'll show it to you again. And then once that comes into your plugin, you just say save, and then the replay test gets saved. So then it's just local versus remote. It's not any different. I'll show it to you again maybe. So you can just go to filter and you can just define a source and you can say remote server and then just give the unlocked application server URL, and then from here just says check for sessions. So right now there is nothing there, so new sessions won't come, but yeah, sorry.
What do you call a sessions in that context?
Yeah, so one run on one machine is a session.
Okay.
So for example, you made a code, say you built your code and then you deployed, and now the application server is running.
Okay.
As long as it runs, it's one session.
Okay.
Every time you make a code change and redeploy, that's a new session.
Okay.
Yeah.
And within one session, if you have multiple calls and that you want to replay a specific one,
Yeah, so again you apply for class filters. Then you
then
say, hey,
okay.
just include this class, exclude this class, include this method, exclude this method. Did you get this or?
Yeah, but if I, how do I pinpoint? Because here I can include classes and methods, but if I want to pinpoint a specific call
Yeah.
with specific arguments,
Yeah, so there is one more thing here, follow
Okay.
method in editor. So what this does is wherever you are going and wherever you are clicking that method particularly, it would just pinpoint on that.
Okay.
So you don't need to even worry about methods, classes, this and that. You just need to click this, follow method in editor, and then in the live view you will see just what is, like wherever you go, only those methods will open. So that's the way of pinpointing exactly where you want it to be.
You only have one, for one code path, you only have one
Yeah.
data set. Okay.
So one code path you can have multiple, but then you can again say deduplicate this and then show one. From remote, yes, you will have just one, but locally you can run it several times and you can still see.
Okay.
Yeah.
Okay. Now I get it. And so if you would want to catch, if you want to know how to replay for exceptions, for example,
Yes, yes, you can say just show me exceptions.
Okay,
Yeah,
then I
yeah.
need to have an exception in my codes to
Yes,
show.
yes,
Okay.
yes. So it would define the filters accordingly, and
Yeah,
then you
okay.
would have to
That
say.
means I cannot catch, for example, if there is an error in some computations, I mean, a computation of taxes to apply to a product, and that's just wrong in some if branches, but there is no exceptions thrown.
No, so the way, yeah, so you're right. So the way that is to be debugged is, so I'll show it to you. That's very interesting. So what you do is you put a debug point and you just replay that with the mocks enabled. So no API call, nothing happens, and then you can actually replay the real scenario. So I'll just show it to you. So 1 second. Installed the thing.
Do you support other IDEs as well?
No, we love IntelliJ. Yeah, you're the IntelliJ fanboys. Don't love Eclipse. Sorry, what? Yeah, so right now the replay is 1 second. So essentially in live mode itself, right, you can actually select this and you can just click on it is also replaying. Just give me a second. Yeah, so you see this add new customer. You can actually just click on it and it just replays. I think we've removed that functionality because of some reason, but so then what you do is click on this debug endpoint. So we use IntelliJ's debugger only, and then just replay. What then happens is it comes there as a debug, like it would just as if you are debugging on a remote machine. I think we've removed that, but it's there. So yeah, we removed that for a reason. So it was causing some issues. But essentially, you put a debug point and then pick that input, pick that particular case, and then just replay. And everything else gets mocked, so you don't have to worry about some external API call or something like that. You can exactly say if how this if else condition went through, like, right? But yeah, maybe I'll send you a video or something. So yeah, but it's there. It's there. In fact, even for a code change, if you do, for a code change also you can replay just that and see how the output is looking like. Yeah, anything else? Please star us on GitHub and use if possible. But yeah, and if there are any issues, we are happy to resolve. This is our website. You can be in touch with us using this Discord channel. Yeah, and then GitHub is this. We are again under open MIT license. We are open source. So star us if you like, and yeah, stay in touch. Thank you guys.